in Canada, relative sea level trends are an absolute mess in this region. You have stations that show very clear and distinct patterns of relative sea level fall in sort of the colder colors on the map, and then you have stations that show very clear patterns of relative sea level rise in the hot colors in the map, and in some cases those stations are sitting right next to each other. They're adjacent to each other. So what drives this pattern? Well, in the Pacific Northwest, it appears that it's not, very, very small-scale variability in the eustatic sea level signal. It's actually because vertical land movement is a mess. So this is an attempt to get at that using continuous GPS data. Again, this focuses primarily on Washington, but you can see that over very short spatial scales, there is large variability in estimated rates of vertical land movement, which drive those patterns of relative sea level that you saw in the previous slide. So this suggests the need to me to take sea level projections one step beyond the regional and really to communityize the sea level rise projections, to do them at the community scale, to take into account, at least in the Pacific Northwest, this variability in vertical land movement that can lead to large changes in projections for a particular community. And the argument that I make is that you really need to do this to provide the most meaningful and credible information to communities, and my experience suggests that that maximizes the likelihood that it's going to lead to effective planning and adaptation. So what are community scale assessments? What does that mean when I say that? I don't really have a clear definition for what that means, but it definitely takes place at a relatively small spatial scale. And really the spatial scale is it would be defined by the spatial